Welcome to the chapter overview for elasticity. This is chapter 6 in the PDF, chapter 5 in the textbook, and thank you for joining me. What are we going to learn in this chapter? We're looking at elasticity, what it is, what it means, how do we calculate and determine what price elasticity of demand is, and whether that tells us what the sensitivity to changes in price actually are for this particular product. We'll also look at the income elasticity of demand, as well as cross-price elasticity of demand, again, to measure the responsiveness of the demand to income, as well as cross-price based on substitutes and other goods. We'll also look at price elasticity of supply, the sensitivities or the responsiveness of the quantity supplied in terms of price. And we'll also look at how all of these factors influence the elasticities that we're going to see visually as well as measured in some of the calculations. And then finally, we'll close it up looking at the incidence or burden of a tax and see who bears that burden based on its elasticity, how that elasticity actually determines who pays the burden or the incidence of a tax. So we're going to look at all of those things, and I'm glad you're joining me. Hope you find this helpful. First, we start by looking at the idea of furniture stores having sales. Mattress stores do this too. Why? Why is it that these places have sales, but yet gas stations don't? Well, it's because of elasticity. It's because when it comes to putting gas in a car, there aren't a whole lot of other options. There are no close substitutes. But furniture stores, dime a dozen. There's plenty of mattress stores and places where you can get a new mattress. But gas stations, well, there's only one thing you can put in your car if it runs on gas. Maybe it's a hybrid and it runs on electricity too, but that's about it. There aren't a lot of other options. No close substitutes. So this is why we see gas as being more inelastic than furniture. Furniture, much more elastic, much more sensitive to changes in price. And we'll take a closer look at this when we get to the price elasticity of demand. So the law of demand says that consumers are going to buy more when prices go down. The quantity demanded is going to increase when prices drop. And the quantity demanded is going to go down when prices go up. They're inversely related because the law of demand says as the price drops, the quantity demanded will rise. And as the price rises, the quantity demanded will fall. And elasticity is going to be how we determine how much it falls or how little it falls. And we use that elasticity to determine that sensitivity to those changes in price. How much of a significant impact or how much of a minimal impact is this going to have? So we start by looking at price elasticity of demand. This is measuring the sensitivity in terms of quantity demanded in response to a change in price. So when the price rises, how does that impact the quantity that is demanded? Well, it's based on price elasticity of demand. And this is going to help us determine those sensitivities. We use the formula percent change in quantity demanded over percentage change in price to determine the price elasticity of demand. And we'll talk about what that number means here in a moment. So price elasticity of demand, essentially, we get this by calculating the percentage change in quantity demanded over the percentage change in price. Now, how do we get that percentage change? Again, new minus old divided by old times 100 essentially gets us that percentage change. So if it's percentage change in quantity demanded, it is the change in quantity demanded, new minus old, divided by the initial quantity or the old number. So new minus old divided by old is times 100 is going to get us the percentage change in quantity demanded. And that's our numerator. Our denominator then is percentage change in price. That change in price, again, new minus old, divided by the initial price, that's the old number, times 100. And that's going to give us the denominator. So we have the numerator, we have the denominator. This is price elasticity of demand. And as we looked at in class, taking this formula, new minus old divided by old times 100, is going to give us those elasticity numbers. And as we can see here, that is going to tell us what kind of impact this is going to have in terms of percentage change. Now, that will then go into the either numerator or denominator, depending on whether it's quantity demanded or price, to determine what the elasticity is. If that number is greater than 1, it is elastic. If it's less than 1, it's inelastic. And if it's exactly 1, it's what we call unit elastic. And again, we'll drill down into those in a second. Just a reminder that on the chapter notes are explainers from 5 other resources on elasticity of demand explaining this topic that I think you'll find helpful. So please use them. These are things like ACDC Econ, Jason Welker, Khan Academy, Marginal Revolution University. All of these you'll find helpful in terms of other ways to explain the same topic we're covering here on price elasticity of demand. But a lot of times it's helpful to see it from another perspective, and I encourage you to do that. So if the price of each of the following goods doubles, the increase in quantity demanded, or decrease in quantity demanded, is going to be different based on these goods. That's whether or not they are inelastic or elastic. Taco Bell tacos, as much as you may enjoy them and have to have them, are not inelastic goods. We don't have to have Taco Bell tacos. There are alternatives. There are close substitutes in which we can substitute those Taco Bell tacos for something else if the price were to double. That's unlikely for medicine or gas. Even for milk. What else are you going to put in cereal? Water? Seriously? And luxury yachts, very elastic in nature. So what we see here is very different sensitivities to changes in price based on the goods we're looking at. And that's why our price elasticity of demand is really helpful, because it's measuring that response to a change in price. And this is really helpful for businesses that are trying to figure out how much should we raise prices? How much should we be sensitive to those changes in price? Well, it's going to depend on how elastic or inelastic your goods are. That's why it matters, because it's going to help them determine what to charge and when, also how many substitutes are in the market that people can switch to if your product is too high, and whether the government is going to be looking at your goods in terms of taxing them, because the incidence or burden of the tax based on the inelasticity of the good is such that the government feels that people will buy it anyway. So all of these have a factor in price elasticity of demand. Now, inelastic demand is the idea that, hey, milk is 80 cents. We're going to buy a lot of it. $2.40, you're still putting the milk in the cart. What's going on? Well, the good is very inelastic. We have to have it. Again, what else are you going to put in your cereal? Water? Really? No. So the idea here is that this good, milk, is very inelastic in nature. This is the idea that the quantity that is demanded is insensitive to a change in price. So here you have a situation in which people are essentially a slave to the price. You'll pay whatever it is because you need to have the good. And these are things like gas, milk, diapers, a great one, and toilet paper like we saw during the coronavirus pandemic. The idea here is people are going to pay it. Why? Because they have to have the good. So if the price increases, the quantity demanded is going to fall a little bit, but not a lot. And if the price decreases, again, quantity demanded may increase a little, but again, it's not going to be a significant change in quantity demanded. And that tells us that the good is inelastic. The demand for that good is inelastic, leading to a much steeper demand curve that's downward sloping. So some goods that we can see here that are different in this nature, the inelastic goods, things like eggs and gas, as we've mentioned already, these have a price elasticity of demand that is less than 1. And that less than 1 number tells us that the good is inelastic. If the price elasticity of demand is greater than 1, then we can see here that the goods are elastic. The demand for those goods are elastic because they are greater than 1. And if the changes in price are equal to the changes in quantity demanded, it comes out to a price elasticity of demand that is exactly 1. And this tells us that the good is unit elastic, meaning any changes in price are offset by changes in quantity. Net, they cancel each other out. So, based on this idea of inelastic goods, we know that the characteristics of inelastic goods, especially for gas and insulin, 2 really good examples here, are that they have few substitutes. You can't really switch to another particular item. These are items that you need. You don't have a lot of other options. Sure, you could take a bus. Sure, you could join a carpool, but you still have to put gas in the car, even for the carpool. So gas is a necessity. And the idea here is that you need them now. You can't wait and say, hey, I'll do these in 6 months. With insulin, you could be dead in 6 months, so you don't want that to happen. And then again, the idea here is the elasticity coefficient is less than 1 in terms of the impact. It would be less than 1 here for the price elasticity of demand. That tells us that the goods are inelastic. And that leads us to this key graph. The idea of perfectly inelastic demand, it is a vertical line. Think of it as an I for inelastic, because the good is less than 1 in terms of its coefficient, its price elasticity of demand, and it is a good that people have to have. There are very few substitutes. It is an item that people have to have, and they're going to spend a portion of their income in doing it. Now, let's switch to elastic demand. Here we have cola for $1 on the left-hand side, and notice on the right-hand side, the cola is now $3, and the guy's walking away. He's like, forget it. I don't need that cola. I can find something else. Why? Because there are other substitutes that are out there. He could buy Coca-Cola. He could buy Pepsi-Cola. He could buy fruit juice. He could buy tropical punch. He could buy lots of other options. He could even buy water. And those are alternatives to what we see here. So some qualities and characteristics of goods that are elastic in demand. They are much more sensitive to changes in price. And notice the curve. Notice it is much more horizontal than the curve we saw that was inelastic. This means that as the price increases, quantity demanded is going to fall a lot. We're going to have a much greater decrease in quantity demanded as a result of a price increase. And that also means, conversely, if the price drops, you're going to see quantity demanded increase by quite a bit. And this is because people are sensitive to changes in price. So if the good goes on sale, people are going to buy more of those goods. The quantity demanded is going to increase. Much more sensitive to changes in price, thus the flatter curve that we see here. And some good examples of this are soda, boats, luxury items. Real estate is a good one. And we see gold as well. Again, luxury goods, I don't need to have them. I don't have to. There are plenty of other substitutes that are out there. They are luxury items. I'm spending a large portion of income on them, so I'm much more sensitive to changes in those prices. And I've got plenty of time to decide. I don't need to do it today. I don't need this right now. And that's where furniture and mattresses come in. We've got plenty of time to decide. It's the sales that want to get people in the door. And then again, the elasticity coefficient, percentage change in quantity demanded over percent change in price, is greater than 1. So if it is greater than 1, the good would be elastic in terms of its price elasticity of demand. And that is typified in this key graph. The perfectly elastic demand curve is a coefficient of infinity if it's perfectly elastic, but it's a horizontal line. And notice the luxury goods, the gold, the jewelry, the yachts, the home in the Hamptons, all of these items are perfectly elastic. They're ultra sensitive to changes in price. And so as a result of this, we are going to not need them. We're not going to buy them right away. We're going to wait for a sale. We're going to wait for a good deal because they are perfectly elastic in terms of their demand. Okay, so looking at the curve then, the downward sloping demand curve we've talked about since, chapter 2, the idea here is this demand curve elastic or inelastic? And the answer is that it depends. It depends on where we are on the curve. And this is important because if we're in the lower portion, we see this as more inelastic demand. In the upper portion, we see this as more elastic in nature. And then if it's right split down the middle, this is the point of unit elasticity. Those changes in price are offset by changes in demand. And as a result of this, they have a coefficient, the price elasticity of demand coefficient is 1. Any changes in price are offset by changes in demand. Net, they cancel each other out. So this leads to a much more inelastic curve on the lower end, more elastic on the higher end. And the idea here is, again, the percentage change in quantity demanded over percent change in price is leading to a number that is less than 1 down here, greater than 1 up here, and again 1 halfway in the middle. So what this tells us is that on the upper end, the more elastic portion, people are going to be much more sensitive to changes in price. These prices are going to be higher. They're spending a larger portion of their income on them. And so the sensitivities to those changes are going to be much more significant. You lower the price here, you're going to see a much greater quantity demanded than you would if they were down in this more inelastic portion of the curve. Down here, you lower the price, you're going to see some change in quantity demanded, but not nearly as much as you'd see in the elastic portion of this curve. And that is because of the quantity effect and the price effect. So at higher levels of output, this is the lower end, that inelastic portion of the curve, you're going to see the price effect is stronger. And think of this as the Walmart effect, the idea that we're going to lower the price and people have to buy the goods. They're looking at them going, why wouldn't I pay $1 for that? So you're going to get their money. And the idea here is by lowering that price, they're going to make it up in volume, thus the Walmart effect. At lower levels of output, the more elastic portion of the curve, you're going to see the quantity effect is stronger. They're going to be selling that item for a greater quantity of money, and so a greater price. And so as a result of this, the lower levels of output just are going to have an impact on the quantity effect being stronger here, because you're not making it up in volume. You're not selling more units. You're selling fewer of those units, but they're at a much higher price. So the price effect is smaller here. It's the quantity effect that is going to be stronger. So what is the point? Well, this is not slope. Elasticity is not measuring the slope, which is why it's so important that you look at calculating price elasticity of demand as the percentage change in quantity demanded over the percentage change in price, because this elasticity varies along the curve, as we can see here. Much more inelastic in the lower end, much more elastic in the upper end. And so ceteris paribus, we're trying to simplify through this graphical representation what is happening here, what is actually being displayed. But we know that at the lower end, lowering the price isn't going to have as much effect on total revenue, which is where we're going next to determine whether or not this is inelastic or elastic. So we see by lowering the price in the more elastic portion of the curve, lowering the price is going to lead to a greater quantity demanded. That's not going to be the case down here in the more inelastic portion of the curve. So let's look at one of those graphs actually from your text, looking at this and breaking down this same downward sloping demand curve. Notice the point of unit elasticity. This is where changes in price are offset by changes in demand. That's the unit elastic portion of the curve that we see. Beneath that is the inelastic portion of the curve. This is the idea that price effect is stronger because total revenue is going to be greater because the goods are inelastic. You have to have them. So your changes in price are going to affect quantity demanded in a much smaller scope than in the upper portion or the more elastic portion of the curve. Lowering the price here is going to have a significant impact in the quantity demanded, and that is because demand is more elastic here. A higher price is going to reduce total revenue. A lower price is going to increase that total revenue. And that is using the total revenue test, which we'll talk about here in just a second. So the idea here is key graph 22, these changes along the demand curve in terms of elasticity and inelasticity basically boil down to this. The upper portion of the curve is elastic, much more sensitive to changes in price. Lowering the price by a little bit is going to increase quantity demanded by a lot. And lowering prices in the inelastic portion of the curve, coefficient of less than 1, is going to lead to less, a little bit less of quantity demanded, an increase in quantity demanded if you lower the price a little, but not nearly as great as what we would see in the elastic portion of the space. Total revenue is going to remain pretty unchanged in the inelastic portion of the space if you raise or lower the prices. You're going to see major differences in total revenue when you raise or lower prices in the elastic portion of that curve, and that is significant. So elastic or inelastic? Well, this matters. And as we can see here, beef being more elastic, gas more inelastic, is all based on this, on the data. Again, a coefficient of less than 1, it's inelastic. A coefficient of greater than 1, it's elastic. And unit elastic is 1 because the changes in price are offset by changes in quantity demanded. So that's what we see there. So again, to visualize this, just to break this down, looking at this as a perfectly inelastic curve, you have a coefficient of 0 essentially there. That is the straight line, the eye, if you will, the eye of inelasticity. Relatively inelastic curves are downward sloping, but have a coefficient of less than 1. And this is where calculating percentage change in quantity demanded over percent change in price leads to a number that is less than 1. If we have a number of 1, a coefficient of 1, this would be unit elastic, meaning, again, offset in, price changes are offset by changes in quantity demanded, and it's basically canceling each other out. If we get to a coefficient that's greater than 1, we know that it's relatively elastic in terms of its sensitivity to changes in price. Lowering the price here is going to increase quantity demanded by a lot more than what we would see over here in relatively inelastic spaces. And then the last one, we have a coefficient of infinity. This is the idea that we have a perfectly elastic curve. It is the horizontal line that we see here. And this is telling us that the sensitivities to changes in price are everything. It is all about changes in sensitivities to changes in price. Now also notice we don't have negatives here when it comes to calculating price elasticity of demand. These are absolute numbers. So if you get a negative, they would still qualify as whole numbers because we would want a number that is greater than 0 and somewhere either from 0 to 1 or above 1 for areas of inelasticity and elasticity. But there is also another way to look at elasticity of demand for a good, and that is the total revenue test. That is the idea that we have price times quantity to give us what the total revenue is for this particular item. So notice here, yellow being the initial and red being the new price. If we raise the price and total revenue increases, we've got more revenue as a result of the price increase, we know that people have to have the good, so they're going to buy it. That tells us that the good is relatively inelastic in terms of its demand. If we raise the price on an elastic good and the total revenue falls, we can see this good is elastic or relatively elastic, because look at the quantity demanded has fallen quite significantly actually. From all of that yellow space was our total revenue, and now it's only red. That tells us that the increase in price has actually caused a significant decrease in quantity demanded. That tells us that the good is relatively elastic. So if we look at elasticity changes in terms of total revenue using this price times quantity method, we can a lot of times check our work. If you know and it can calculate the percentage change in quantity demanded over percentage change in price, we can then get the coefficient, and by using the total revenue test, we can double check our work. Because if the price increase causes total revenue to increase, as we see here, we know that total revenue is going up, and as a result of the price increase, we are still getting people to buy the product. That tells us that the good is inelastic. If the price decrease causes total revenue to decrease, then that also tells us it's inelastic, because people are still buying the product. It's our price decrease that actually caused total revenue to decrease, not a change in quantity demanded. Now, in terms of elastic demand, if you raise the price and total revenue falls, that tells us the good is very sensitive to changes in price, and thus it's elastic demand that's at work. Just like if the price were to decrease, you cut the prices, you're putting something on sale, think furniture stores, and the total revenue increased, that tells us that quantity demanded is increasing, and that tells us that they're taking advantage of those sales. The goods are very elastic in nature. And again, if those price changes lead to quantity demanded changes that result in total revenue remaining unchanged, or basically price and quantity canceling each other out, this is the area of unit elasticity. They're both equal to 1 as a result of what we see here. So again, this idea is what we see of the elastic portion of the curve versus inelastic. A couple of different ways we've looked at today in terms of how to spell that out, how to address it, and the idea of the price effect and quantity effect at work. We see price effect down here in the inelastic portion. We see quantity effect in the elastic portion. What does that mean? Well, if you're going to sell more and you have to lower the price, at higher levels of output, the price effect is going to be stronger. And the reason for that is because you have higher levels of output. And as a result, you're going to do what's called the Walmart effect, the price effect at work. By lowering that price, people are looking at it and saying, oh, I can't live without that. I've got to have it. And what a great price that it's at. I have to buy that good. And so they make it up in volume. And they're able to do that here. Now, at lower levels of output, this is the elastic portion of the curve. We've got the quantity effect that's stronger. These are the luxury goods. These are the things we're selling at a top dollar. Think jewelry, think luxury boats, and other vacation homes and that kind of thing. Lowering the price by a little is going to increase quantity demanded significantly, because people are waiting for the right price to basically gobble up those items. So that's where we see that the quantity effect is stronger, because we're going to make it up in each item that we sell by cutting the price by a little bit. So at higher levels of output, we see the price effect is stronger. At lower levels of output, in the elastic portion of the curve, we see the quantity effect is stronger, because you're selling those units, and you're selling fewer of them. You're not doing this in volume, but you're making, but by selling one more, you're making more off of that one, which has a significant impact on the quantity effect here. Okay, now we're going to shift gears. As I mentioned, a bunch of explainers on price elasticity of demand. I would encourage you to check those out. I think you'll find them helpful. So just check the chapter notes, or you can Google them, and you can find them. AC/DC's there, Jason Welker, Khan Academy, Marginal Revolution University, Economics Online. All of those I think you'll find helpful. Now let's shift gears and talk about the price elasticity of supply. So now that we know the price elasticity of demand, the idea here is price elasticity of supply. So how do we calculate the price elasticity of supply? Well, if you know the price elasticity of demand, the other three formulas to know are really going to be easy, because price elasticity of supply is the same thing. You're only replacing demand with supply. So percentage change in quantity supplied over percentage change in price is going to give you the price elasticity of supply. Same thing we talked about with price elasticity of demand. So this is measuring sensitivity to how much we're going to supply in the market. Producers or businesses are going to produce, and how much they're going to produce is actually going to be affected by changes in price. So the best example, one of the best examples we can use here is fidget spinners. Fidget spinners aren't very expensive. We know this. But are they inelastic or elastic? And what we saw was during the craze, we could see where in the short term, this was more inelastic, and it became more elastic in terms of price elasticity of supply as time went on. So in the 2017 craze of fidget spinners, what we saw is manufacturers really trying to make them quickly and trying to get the product out to market. But they were very sensitive to changes in prices. So we saw a lot of people trying to jump on the bandwagon, trying to take advantage of the fact that this market was available and the craze that was out there. But it was really hard because you wanted to get those to market right away, and there's a significant amount of time that it takes to get a manufacturing facility up and running to produce these, then to package them, then to ship them, then to get them into stores. All of those things take time. So in the short run, it's very inelastic in terms of trying to address it. In the long run, it's much more elastic in terms of trying to address those issues. So price elasticity of supply shows the sensitivity that businesses and producers have to a change in price. And time limitations definitely have an impact here. Producers need that time. As I mentioned, you have a factory in China, you're making these products, or you're starting to make these products. Now you've got to package them, you've got to ship them out, you got to get them on a boat, a barge, and basically ship them to places that are going to buy them. Then you've got to get them from the dock, through customs, onto the shore, into trucks, and into the stores, and then on the shelves, right? All of those things take time. You're not going to do that in a day. So this is where we see that there is some inelasticity because of the short run implications of this supply. Now in the long run, we can have a much more elastic supply, and we're much less sensitive to changes in price. But what we see here in the short run is price elasticity of supply, and most goods fall into this category, especially things that are technological changes. As they become older in terms of product, they become cheaper, they become more prevalent, they become more widespread. There are lots of them that are out there. There are a lot of close substitutes. There's a lot of other options. So they become more elastic as time goes on because of more facilities able to produce them, able to make them. People want to take advantage of the profit motive and sell more of them. So there's a lot that happens there to move from that inelastic supply to more elastic supply. And then perfectly inelastic supply would be the same as what we saw here. The quantity supplied isn't going to change. You got a set quantity supplied, essentially the vertical line we talked about before. So let's look at some characteristics that kind of break down the differences between inelastic and elastic supply. Inelastic supply is very hard to produce. Again, we've got some barriers to entry. Probably time is going to be a big factor here because we can't do them quickly. There's not a lot of alternatives, and it's probably going to cost more to get this thing up and running. We'll find new ways of doing things faster, smarter, cheaper, and more innovatively down the road, but the idea here is it's going to take time in order to make that happen. Here's where we have an elasticity coefficient, again, percentage change in quantity supplied over percentage change in price, that is less than 1. So that's inelastic supply. Let's go over to the right side and look at elastic supply then. Here is where we see that it's much easier to produce. There's probably been some time involved that has taken place in terms of being able to produce this more and to do it more effectively. to be more effective in terms of its production. There are lower barriers to entry, probably because there's a lot of firms involved now that are jumping on the bandwagon to take advantage of the profit motive to make money in selling these fidget spinners or whatever the case may be. There's a lower cost because, again, they're doing it more innovatively. They're finding cheaper workarounds to make it happen. There are alternatives to not just producing the goods, but also finding the resources to produce the goods. And here is where we would have an elasticity coefficient that is greater than 1. Again, percentage change in quantity supplied divided by the percentage change in price. We're going to have a coefficient that is greater than 1 here if it's elastic in nature. So if we go back to the supply curve in terms of the fidget spinners, we can see in January, very hard to produce. People are jumping on the bandwagon. They're in March and April. We start to see an increase. Then we start to see an exponential growth of online sales. And the reason for this is because a lot more manufacturers are out there trying to sell it and take off and make money off of the product. So we see a significant increase. So this is only in 4 months that we're able to do that and move from inelastic supply to much more elastic supply in terms of what we see here. So time definitely speeds up and allows more innovation, able to produce products easier, faster, cheaper, and in less time for sure. So that leads us to key graph 19, this idea of perfectly inelastic supply. Think of this as a parking garage in an urban area. Maybe it's near a metro station. And there is the parking garage. You build it. You're not going to take out spaces because you're sensitive to changes in price. You're basically a slave to the price at that point. The supplier is because you essentially have built the product and now you have to sell it. So you are basically a slave to the product, and that creates the vertical or the I a curve that we see here that is a vertical line. That's the inelastic supply curve. So I use the parking garage example here because it's always hard for students to understand like what would be a good example of this. And this is a good one because it really addresses the idea behind there's inelastic supply. I'm supplying this product and now I can't take it off the market. I mean, I could tear down the parking garage, but then I'd have to build it again and it would cost even more money to do so. So cost benefit analysis there not well. Therefore, I am not really sensitive to changes in price. I'm going to lower the price. If other parking garages are lowering their prices, I'm going to have to do the same if I'm going to get cars into my lot and make any money. And that is the inelasticity that we see here. Now, conversely, we see perfectly elastic supply as being a horizontal line. The supply curve is completely horizontal. And the example I use here is resources that go into making pizzas. There are pizza places everywhere, and don't we love a good pizza? But the resources that go into those vary quite widely, and this is an industry that is very sensitive to changes in price. So if the price of those resources go up, pizza makers are going to switch to other products. They're going to find other flour manufacturers, other tomato manufacturers and farmers, those making cheese or selling cheese, cheese producers. They're going to find other products and resources. So an industry that is very sensitive to changes in price in terms of what we see here would probably be the best example in terms of looking at a perfectly elastic supply in terms of how that plays out. So in terms of visualizing this elasticity of supply, it is an upward sloping curve, but in this case of perfect inelasticity, we see a vertical line, a coefficient of 0. If it is relatively inelastic, again, this is a coefficient of less than 1, so think 0.5, 0.78, 0.92. These would all be relatively inelastic, meaning that any changes in price are going to have a relatively small impact on total revenue and a relatively small impact on quantity demanded because people are buying the product or selling the product in this case of supply. They're selling the product here because of suppliers. This is the parking garage mentality. Unit elastic, any changes in price are offset by changes in quantity demanded. So you're going to see net a cancellation there, which is a coefficient of 1. Relatively elastic or perfectly elastic, these are the pizza resources going into making pizzas, pizza suppliers. Relatively elastic, very sensitive to changes in price. They're going to have an elasticity coefficient of greater than 1 because very sensitive to changes in those prices as a result of trying to find other resources. So if those prices go up, the quantity demanded is going to plummet. The quantity supplied is going to plummet in those places because they're going to have to be very sensitive to changes in price if they're going to move that product. Otherwise, they're going to find other suppliers. They're going to find other resources to make that happen. Okay, and again, for price elasticity of supply, some other explainers and resources here that I think you'll find helpful. Again, check out the chapter notes for those explainers. Again, percentage change in quantity supplied divided by percentage change in price, and you can't go wrong on price elasticity of supply. Now, looking at cross-price elasticity of demand, this is going to measure the sensitivity of the quantity demanded of one product to a change in the price of a different product, okay? And you're like, what on earth is going on here? What is cross-price elasticity? Well, let's talk in more detail about it. Again, sensitivity to changes in quantity demanded of one product because of the change in price of another product that is out there. And so some examples here that we look at, let's start by looking at the formula, which you see in yellow. Percentage change in quantity demanded of product B is going to be divided by a percentage change in price of product A. So again, we're just taking the elasticity of demand formula and we're just substituting product B and product A here. So take the two products, whatever information you have on them, and plug them in terms of percentage change in quantity demanded of one product divided by the percentage change in price of the other product. So in this case, what you're going to see here is if the price of hot dogs is increasing by 20%, the quantity demanded of burgers is going to increase by 40%, but the quantity demanded for hot dog buns is going to decrease by 40%. Why is this happening? Because of cross-price elasticity of demand. If the price is increasing in these for these hot dogs, the quantity demanded will fall, which also means that the quantity demanded of hot dog buns. If I'm not buying hot dogs, I don't need hot dog buns. Conversely, we know that the price increase of hot dogs is going to shift demand for hamburgers because the related price of related goods, the R in merit, is shifting demand. So the quantity of the burgers is going to increase in terms of quantity demanded because of the related price of a related good that is going up, leading to a greater quantity demanded of hamburgers because of that shift in the demand curve. So if the coefficient is positive, showing a direct relationship, then you know that the goods are substitutes. The idea is you can substitute one for the other, hamburgers, hot dogs. If the coefficient is negative, okay, showing an inverse relationship, then you know they're complements, okay? And a great way to think about this is if the number is positive, then you have a substitute. Think about this like you're in school and all of a sudden you find out you have a substitute teacher. Oh, what a positive day. You just brightened my day by finding out that I have a substitute teacher in that class. I thought we were going to have a quiz. Now I know I have a reprieve. That is a positive move. So substitutes positive, coefficients of complements negative, the goods are complements. The idea of a negative number there, more complement. And the idea there, that is hot dogs and hot dog buns. So if there's a negative coefficient, which in this case there would be, you have increase in price of hot dogs and then decrease in the quantity of hot dog buns, leading to a negative number, you essentially have a negative coefficient, then it's a complement. If a positive number, hamburgers and hot dogs, both positive there, showing a direct relationship, then we know the goods are substitutes. And that really is the driver of cross-price elasticity of demand. Now, if we look at two examples, the price of inkjet printers increases by 25%. The quantity demanded of ink cartridges is decreasing by 50%. Now, we know that inkjet printers and ink cartridges are going to be goods you need to use essentially together. So by looking at this, if the price of inkjet printers is increasing and the quantity demanded of ink cartridges is decreasing, we're going to have a negative number, which tells us that they're complements. So at this point, you know, you can find out their complements without even doing any calculations. But we know percentage change in the quantity demanded of one good, in this case, quantity demanded of ink cartridges, decreases by 50%. divided by the percentage change in price of the other good, an increase of 25%, 50 over 25 simplifies to 2. And it's a negative number, so we have a cross-price elasticity coefficient of -2. We know that this is a complement as a result. Now, the price of Netflix increases by 40%. Quantity demanded of Blu-ray discs increases by 10%. Both of these are increasing in terms of their price and quantity demanded. So we know that it's a positive number, and that tells us it's a substitute. But by how much? So the quantity demanded on top, price beneath, which is 10 over 40, simplifies to 1/4, or 0.25. And that gives us the substitutes and the cross-price elasticity of demand coefficient of 0.25 that we see here. And hopefully you'll find that helpful. That one's a pretty easy one. If you just remember the price elasticity of demand model and just substitute one product for the other product, and a lot of times, like in these examples, they give you which one is the price and which one is the quantity demanded. Then you can just plug in those numbers and you're done. And again, I have explainers for you, or I should say they have explainers for you to explain this in more detail. Again, check out those on the chapter notes. I really think you'll find them helpful. But that's cross-price elasticity of demand. All right, now we're going to look at income elasticity of demand, and this is measuring how a sensitivity in quantity demanded is a result of a change in income, a change in job status. If we fall on hard times and people lose their jobs, they're going from normal goods to inferior goods. This is income elasticity of demand. They're going to change the quantity demanded of particular products that they're buying. So this is income elasticity at work. We calculate this by looking at percentage change in quantity. Again, same as elasticity of demand, only here, instead of percent change in price, it's the percentage change in income that we see here. So as the income increases 20%, we can see the quantity decreases 15%. Then the good is, and we would calculate this by looking at the quantity decreasing 15%, again, negative number, income increasing 20%, positive number, and then that tells us that this is negative because one's decreasing, one's increasing, so we have a negative number there, showing the inverse relationship, and then we can see that the good is inferior. So this is an inferior good as a result. So if the income falls, the income increases by 20%, and the quantity decreases by 15%, we know it's an inferior good. Now, if income falls by 10% and quantity falls 20%, we have two negative numbers. Now we know that it's positive in terms of the direct relationship here. So we're going to see that it's a normal good because of the idea that if income is falling by 10% and the quantity is falling by 20%, we know that these goods aren't being purchased because your income is falling. These are normal goods because these are things you would normally buy when you have income, and when the income starts to disappear, so does the quantity demanded for those goods. So again, income elasticity of demand, very easy to remember, percentage change in quantity demanded over percentage change in income. And that's what we see here in income elasticity of demand. And again, I have explainers, or they do, of this income elasticity of demand that I think you'll find helpful. So do check those out if you don't quite understand that. Okay, a couple of items and then we'll be done with this chapter. I want to go to a couple of key graphs just to finish this up. This is key graph 23. And now, so what we need to look at here is, in the last chapter, we looked at the idea of government intervention and the idea of an excise tax. Now notice that we still have the excise tax, but the elasticity of the demand curve is different. It's much more inelastic than supply is here. Much more inelastic demand curve. Downward sloping, but much more inelastic, telling us that one set of this equation, one group of people, either consumers or producers, are going to bear the burden of this tax. And in this case, because demand is more inelastic, it's going to be consumers. So normally in perfect competition, we would be selling at E1, the price level would be at P1, and the quantity at Q1. But because of this tax, the supply curve is shifted leftward, leading to a price of P2 and a quantity at Q2. Okay, because of this supply curve shift, because of the tax, the R related government actions, right? The R in trice, related government actions, which include subsidies and taxes, would shift the supply curve leftward. This is leading to a higher price and a lower price for producers in terms of what they're going to get out of it. Inefficiency in the market. But notice the inelasticity of the demand curve, much more inelastic. So this is a good that is more inelastic, meaning consumers have to have it, and they're going to pay the tax because they have to, because they need the good. So notice the tax box is much larger than the revenue box. All of this is tax revenue, but the P1 line divides between who's paying for that tax. Everything above P1 is what consumers are paying. Everything below P1 is what producers are paying. So producers are paying not nearly as much as consumers are in terms of the burden of the tax here. So consumers are going to be paying more because that demand curve is more inelastic. So this is going to lead consumers to pay a higher price, producers get a lower price, and consumers are going to bear the burden of that tax more than producers. They're both going to pay parts of the tax, but consumers are going to pay more of it. And this is showing that their demand is more inelastic than the producers, or the supply is, as a result of this. One more that I want to cover, and that is when we have supply that's more inelastic than demand. So notice demand is relatively inelastic in this respect, but much more downward sloping than the supply curve, which is what we see here. So if the tax is being imposed, and in this case supply is more inelastic than demand, think of a tax on parking garage spaces, this would be an example of where the burden is going to fall on the producer. So notice the revenue box is much bigger than the tax box. Again, all of this money going to Uncle Sam, to the government, but the consumer is going to bear less burden of this tax. Why? Because producers are basically going to have to pay this, going to bear the incidence or the burden of the tax. Otherwise, if they pass it along to consumers, consumers may go to other options. They may find other substitutes, such as taking the bus, or walking, or taking the metro, or carpooling, or finding other alternative modes of transportation. So the producer is bearing the burden of this tax in order to keep the revenue coming in from consumers. Otherwise, if they raise it and pass that burden along to consumers, consumers will probably leave. Many of them, because their demand curve is not nearly as inelastic as supply is here. So they can walk away. They have close substitutes. They have other options. And the demand curve being more elastic here than inelastic in terms of in relation to supply tells us that it's the burden on the producer that is going to bear more of that burden. And so the seller is going to pay more of this tax than the consumer. Consumer's going to pay some. That little tax box there is the producer, or excuse me, the consumer paying part of the tax. But they're going to bear, the producer is going to bear more of that burden because they don't want to pass it on to consumers and then risk losing them altogether. That really would really be a significant blow to them in terms of how that plays out. All right, so hope you found this helpful. Take a look at some key terms here. There are a couple of other things that I do want to just mention briefly in a couple of these slides that try and address elasticity equations. These are the four formulas. Here are two. There's two on the next slide. The four equations you need to know. So remember absolute values here. And percentage change in quantity demand over percent change in price is the big one. If you remember this one, you can derive the others from this one. So price elasticity of demand, percentage change in quantity demanded over percent change in price. And we get percentage change by taking new number minus old number divided by old number times 100 is going to give us percentage change. We can use that for price or quantity demanded. And then calculate that. If we get a number that is greater than 1, that tells us that it is elastic, that the price elasticity of demand is very elastic, meaning that it is very sensitive to changes in price. If it is less than 1, then the price elasticity of demand is inelastic, meaning that the rise in a price is going to increase total revenue. A cut in the price is going to decrease total revenue. People are buying the product regardless because the demand is inelastic. Cross price elasticity says percentage change in quantity demanded of one good is going to be divided by the percentage change in price of the other good. And here it's most important in terms of is it a positive or negative number. If it's negative, it's a complement. If it's a substitute, it's a positive. Yay, we have a sub today. And this is the role that they play in terms of cross-price elasticity. A lot of times, they'll already give you that number. They won't even make you calculate it. They'll just say, we have a cross-price elasticity of -2. What does that tell us about these goods? Well, it tells us they're complements because the number is negative. So very easy to calculate. There was really no calculation involved in some of those cases. But again, you can use price elasticity of demand's equation to figure this out because it's exactly the same. The only difference here is you're using two different goods. One good versus another good. Here in price elasticity of demand, it's just one good, but same formula. All right, and then the last two involve income elasticity of demand. And again, that's the percent change in quantity demanded over percent change in income. If it is negative, that tells us it's an inferior good. Think you're eating Spam or something that you would be eating when you are falling on hard times, versus a positive number. And that would tell us that it's a normal good in terms of that. If that is a positive number that's less than 1, it's more income inelastic. Greater than 1 would be income elastic. I have never seen a question that has been that specific on the AP exam questions that I have seen over my years of teaching this course. I've never seen one that's been that specific in terms of income inelastic or elastic. Usually it's just, is it an inferior or a normal good? And then the last equation to look at here is price elasticity of supply. So if we have a price elasticity of supply coefficient that is greater than 1, this would tell us that the price elasticity of supply is elastic. If we have it less than 1, a coefficient that is less than 1, that would tell us that the price elasticity of supply is actually inelastic. And again, if the coefficient is 1, that would tell us that any changes in price are offset by changes in quantity supplied such that they cancel each other out. That would lead us to unit elastic in terms of the price elasticity of supply there. So applying it to businesses with your small business, what elasticities are in place that may impact a business today? You can imagine the sensitivities to changes in price. And there's a whole industry, if you love this sort of thing, there's a whole industry just on pricing strategies. I worked with a lot of people that did just this, just looked at pricing strategies for businesses and how do they look at elasticities of products in order to determine where is the right price point that they can use in order to be effective and sell the most quantity demanded in terms of these spaces. And a lot of it was based on elasticities, based on how sensitive to changes in price are the quantity demanded and quantity supplied. And that really does impact a business because they need to look at that in terms of projecting how much they're going to sell, how much they're going to produce, and how much they're going to move. Think supply chain, how much they're going to move in trucks, how much they're going to need to get to stores so that they aren't flying off the shelves at a point that the stores are sold out, which is great press, but that's no money. There's no revenue coming in when you're sold out. When the media is covering it, that the stores are sold out of fidget spinners and you can't find any anywhere, that's not making you any money. That's some great hype, but if you don't have product coming in to sell, you're not making any money that way. That doesn't help you, and you want to take advantage of those moments so that you can gain revenue from it. But without it, it's very tricky, and that's why pricing strategies are so important. And looking at elasticities of those prices are so critical. So what would elastic demand look like for your business? Is there inelastic demand in that space? How could inelastic supply impact your ability to do business? And further, what elastic supply of resources might you have that you're sensitive to changes in price that you would have to find other suppliers or other resources for? And how would your business respond to changes in these elasticities, these sensitivities to changes in prices? So these are the types of things that businesses look at all the time in trying to address whether or not they are sensitive to changes in price, from resources, supply, to the products that they're selling, demand, quantity demanded, and price elasticity of demand, and how they're going to get those products to market, how they're going to price those products, how they're going to get those products moving off the shelf, and how they're going to deliver profit revenue for their shareholders and for their investors. That really is the key. And elasticity is the backbone of helping to make that happen. I hope you found this helpful. Here are the answers to the take-home quiz study questions for this chapter on elasticity. So here, take a look. Pause as you need to in order to take better notes on this. Hopefully check your work. The take-home quiz is a great resource. There are some tips at the beginning, and then some of these questions are really great to practice your knowledge of elasticity. The Mind Tap is good for this. The take-home quiz is great for this as well. I hope you found this chapter helpful. I'm looking forward to talking with you in the next chapter about consumer and producer surplus and total surplus. How do we calculate those things? It is very easy to do, and we're going to find out how in the next chapter. So I will see you then. Live the 5. Have a great day. Good luck on the upcoming assessment, quiz, test, or AP exam.